Hello everyone, I'm Hwang from Yonsei University. Today, I'm going to present our work, Just One Moment, Structural Vulnerability of Deep Action Recognition Against One-Frame Attack. Human action recognition has been extensively researched in recent years. Action recognition show a significant difference compared to image classification in their general input. Action recognition's input is a video, which has temporal dimension. Therefore, for action recognition, modeling the temporal information is crucial. Many researchers found the vulnerability of DNN-based models by adversarial attacks. An ideal adversarial attack should satisfy two criteria. First, achieve a high falling rate. Second, keep adversarial perturbation invisible. There have been several researches done regarding adversarial attack on action recognition models. However, they could not meet two criteria that adversarial attack should satisfy. In order to find special vulnerability compared to image classification, firstly, we present in-depth analysis of the structural vulnerability of deep action recognition models against adversarial attack. With properties that we found, we could demonstrate the possibility of strong and inconspicuous one-frame attack, which meets two criteria of adversarial attack as I mentioned. Furthermore, we investigate the possibility of finding universal perturbation showing high falling rates in various attack scenarios. We analyze models by adding perturbation generated with IFGSM and uniform random noise to the target frame. We selected three state-of-the-art models, I3D, Slow-Fast, and IRCSN. The following figure shows the most representative result of our research, which represents different characteristics of each model. Among the three, a clear and periodic vulnerability could be found in the I3D and Slow-Fast models. Based on the results found here, we were able to infer that structural vulnerability caused by some structural properties exists. Now, I will go on to explain how the structural properties influence the vulnerability. Based on I3D's first convolutional layer and max plane setting, a 32-frame input is contracted to 8 frames, and as the figure here compares the thickness of the lines, the weights of the first convolutional layer appear to be asymmetric to the temporal dimension. Due to this, vulnerable frames appear every 4 frames. In the case of Slow-Fast, all frames used in 2 streams have become vulnerable. Therefore, they also appear every 4 frames. By the discovery in the analysis part, we conduct robust adversarial attack on action recognition models, aka the one-frame attack. This attack algorithm targets only one frame among multiple frames of the video clip. This results when we target the most vulnerable frame with one-frame attack and is close to a 100% in its success, while other attack method achieves comparatively low success rates. We conduct a subjective test to prove our attack's inconspicuousness. Participants of the test are asked whether or not they could detect any differences between the original video and the compared video. Through these experiments, it can be concluded that our attack shows low detect ratios compared to the other research. Because the video's instant change per frame is difficult to catch with the naked eye, I will briefly summarize the universal one-frame attack method. We update the perturbation with the gradient average with vulnerable frame set for each group. Through the result, we were able to conclude that the one-frame attack garnered a higher universal falling rate even by using a smaller number of videos. In the real world, when we classify videos in real time, attackers need to consider real time and existence of an unknown temporal offset. So we add universal perturbation to 4 frames every video clip length. Ultimately, it was proven that our method is efficient to the real-world scenario. You can find more experiments with details in our paper.